So, what are we doing? This is a stream that is first and foremost primarily for the current beta users of this programming language. It's for me to answer questions that people have and maybe help out with problems and stuff. And then we just invite everybody because why not? Actually, I could think of some reasons why not, but we do anyway. And so initially, I'm going to be answering questions off the private secret beta Discord. And then if we run out, we might go to Twitch chat, but I'll probably be ignoring Twitch chat most of the time. I just scheduled and announced this one like less than 24 hours ago. I think it was 18 hours ago. So this may be a shorter one than usual because we haven't given people as much time to even see that there was going to be a Q&A. So we might have fewer questions. That said, we also have more people in the beta than we ever have because we're accelerating the rate at which we add people. So who knows? It may end when we run out of questions. It may end when I get tired of doing it. We'll see. Okay. So, also, I'm going to need to remember my tea in a few minutes. Okay, question. Regarding compiler intercepting, is it intentional, final, that code blocks are seemingly read-only? Put another way, is it reasonable to allow user-level modification of those structures and have the compiler use the modifications to finish the compilation? Okay. Let me talk about this. So first of all, well, the rest of the question says, currently one can do the slow equivalent by program printing the modified code blocks into a new build string. There is another way. It sounds like the assumption in this question is that you have to make a string to resubmit the code. That is not true. So if you go to modules compiler, right? Well, this file. So what you would do if you wanted to resubmit the procedure as syntax nodes is you would call compiler modify procedure and you pass in the procedure body. And this you can mess around with. Like you can change pointers to the nodes and all that and resubmit. And you don't have to create a string, right? Now, I will say that if you give it malformed input, we're not super careful about checking it right now. So it is quite possible to make the compiler perform badly or to make bad things happen, let's say, by giving this bad input. I'm just making sure there's nothing coming out my headphones. But that's the sort of faster way to do it. Now, it is still a discrete resubmit. Like it's not like you can just modify the body and it'll automatically take. And there's a lot of reasons for that, not least of which is just, avoiding weird data races in a parallel environment, right? But yeah, this is the intended either high performance way of doing things or just, like languages so far, I'm thinking of, for example, D or something like that, that let you submit strings as code. Like that's very useful and it's helpful, but also like if you're doing algorithmic code generation, generating strings is kind of messy and annoying and imprecise in a certain way. And for some classes of applications, you would rather generate syntax tree. And that's why the whole time that we've been making this compiler, it's been part of the roadmap that you can submit anything as syntax tree. And that has a significant impact on the structure of the compiler, I'll say that. Yeah, you should be able to do that. Okay, next question. Feel free to follow up on any of these, by the way, if the answer is insufficient or anything like that. What are the current features goals that you're working towards? In the last Q&A, your answer was relative pointers in Mac compiler, which have since shipped. Okay, and then there's a follow-up question, but we'll do the first one first. The biggest things right now are cross-compiling, making cross-compiling work better, and then making all the language features work well with DLLs and libraries. You know, we made some steps toward that recently, but that's not done. And then making macros better is still on the roadmap because they should be more powerful than they are, and they're like not, right? So that's a thing that I want to figure out. And then in general, just robustness of the compiler and making sure all the features that we have are actually as good as we can make them. Like pushing the features out on the spectrum of how good they are, which sometimes involves changing the features a fair bit. You know, inline assembly we want to make better. There's a little bit of, like right now, if you do small amounts of inline assembly, like there are overhead instructions that get generated that sort of, you know, like eliminate the benefit of doing assembly, right? That's not true, I don't think, for longer blocks of assembly, but you know, stuff like that. There was one other thing that I thought was, I also want to start down the road of making it more of an optimizing compiler before. So there's always a question of like what features come before you do a public release and what features come after. And I don't think, for example, we need to have our own backend very optimizing before a public release. But I think that we do want to dip our toes into the water a little bit and do a few things because, again, that can influence the structure of the compiler and like what features look like and all that, right? And the last thing, which I think is very important, and I wouldn't gate public release on this, but I want to push it forward, is the program visualization and understanding stuff. So we have all these very good facilities for your program to communicate with the outside world, right? I think better than any other language in existence by far, right? And we don't use those that much yet. It's like they're just there. And so I want to do more program visualization and stuff. And so, you know, one of the things is these are a lot of things to do, and we don't have that much of a team working on the compiler. In fact, it's me part-time and then someone else part-time. At some point, we will want to enlarge the compiler team. That'll have to wait till we have the money to do that. But the good news is at some point, we will have the money to do that. Maybe around 7 or 8 months from now. So the roadmap of the compiler looks like for the next, like, say, 6 or 7 months, we're sort of continuing on the at the pace that we've been going on and with the kind of features and work that we've been doing. And then around that time, we start expanding the compiler team to scale a little bit more, right? Not too much, but a little bit. And with scale, you can do things that you couldn't really do without scale. So that is the plan there. I just noticed Twitch chat for a second. Someone says, wouldn't stability be #1 for public release? I mean, stability is always #1. We don't have that much in the way of stability problems. We do when people are using very advanced compiler features or very complex programs, right? That's Like, and those are usually small problems that once somebody sends us a repro, we fix pretty fast. We're not in general, this isn't like, we don't have open source software level of stability problems. I'll put it that way. We have commercial project level of stability problems. But that said, it is a very ambitious feature set, and that just means things are complicated and difficult sometimes, right? So, yeah. But yeah, stability, super important. Both not crashing and generating correct code for your program, because it's not good to not crash but also output the wrong code. Okay. Second part of that question was, what is run comma stallable, which this thing. So what is that? Okay, so this comma stallable is a modifier on run that helps. Okay, let's talk about how run works a little bit, right? So run can run any code in your entire program. In order for it to run code, of course, that code has to be compiled enough that it can be run. And, sometimes you have procedures that depend on other procedures. Sometimes you have procedures that depend on, data that isn't loaded yet and whatever, right? Okay, so in those cases, those procedures can't be compiled. And so that they can't be run if they can't be compiled. Now, we try to detect those situations and not try to run those things. But the problem is, in a systems level programming language, the call graph of all the things you might possibly call is not statically analyzable, right? So you could call through a function pointer. That works at compile time. And the function pointer you call through might be to something that can't be built yet, right? And so it is always possible during compilation that a run directive, we might have to stall it after it starts running and come back to it later, right? Exactly like a multi-threaded operating system does, right? Like if there's one core and an operating system wants to change who's running on that core, it pauses one thing and puts another thing on there, all right? Now, however, we can't just do that. We can't just take all your run directives and make them preemptively multi-threaded, because then all of them would be subject to like thread race conditions at all times. It would be impossible to write a correct program. That would be a nightmare. But what we do is we say, look, if you have a problem where your code is kind of deadlocking on run directives, then you can put this stallable on there. And it means that the compiler is allowed to suspend it and resume it later. And what that means on your side as the programmer is that you're confident that this run will not interact badly with other runs. You know what I mean? Like you're not, for example, using some global variable where you'll be surprised if it changes in the middle because you got stalled in some other run directive ran, right? And that's our way for now of dealing with just certain kind of weird deadlocks that could happen. Yeah. Do they always happen due to exactly that case that I was talking about calling through a function pointer? No. And in fact, there might be some cases where it happens that's the compiler's fault, that it didn't do a good enough job of like looking at your call graph. I'm not sure. But that's what it's for. So if you get a circular dependencies Like what'll happen if we stall a run and then can't continue it? It'll look like circular dependencies with a bunch of runs, or a run waiting on other stuff, and then other people can't run because of that run, right? And so this is how you can get around that in those cases. It's a niche feature that most people should not need. I'll say that. Okay. How many neat general patterns, idioms emerged from the language that I didn't expect? I don't know. That's not something I've taken a census of. I feel like, honestly, not that many, because we sort of designed idioms into the language. Like, here's a very short for loop syntactically, right? Things like that. But who knows? Yeah, there's probably some that I'm not thinking of. What is current angle on how the language will deal with shaders in SIMP or otherwise? Are you still considering transpiling to specific shader languages per backend? Well, okay, so I don't exactly think of that as a language issue, except of course if the features of the language help us do a good job, that's good. You know, it's more of like a runtime library issue, and what do we supply to people? And again, unlike C++, we're not trying to be the communism of runtime libraries, right? If we give people some stuff that works a certain way, for example, if we give people stuff that transpiles, that doesn't mean that we're declaring that that's the way to do it or anything like that. It's like, here's a thing we tried. Okay, so now the shader situation, just in graphics programming generally, is one of the dumbest things that's happened to computing in the history of computing. It's completely asinine, and it makes me angry every time I think about it. That said, like, it's not like we're going to commit to a giant project to try to clean that up, because we have too much else going on, right? So now that said, when we make something like SIMP, yeah, we kind of need to try something. And the transpiling idea is one of the idea that we floated. It's still about the same status. Like, we haven't tried it yet. Maybe it'll work just fine. In fact, you know, like, what is appropriate to do often depends on what's your use case. And for a use case like SIMP, I think maybe even transpiling is ideal, because you're trying to be totally platform agnostic and just give people a way to write shaders, you know? Now, back on the Sokoban game that we're making, we were thinking about doing transpiling there, and maybe that could be like a pilot program for it. But I'm actually not sure it's as useful there. Like, because we already have a shader system set up that's, again, it's completely asinine that we have to do the huge amount of work that we have to do just to do shaders, but just to write functions, you know. But that's what we have to do. So because we already have that system, even though it would be fun to do transpiling there, I feel like we're not going to do it. So maybe I'll do a bounty for it. Like, if there's someone in the beta program who, like, wants to do the transpiling bounty, we could talk about it. It would be a pretty high value bounty because it's a little complicated, but basically, you know, basically we want to have a set of things like basic data types, like the floats plus vectors plus integers and whatever, that we know what they compile into, and then maybe a specific set of functions that you can call that do the same thing both on the CPU and on the shaders, right? And as long as you stay within that set of well-defined things, then we guarantee for you that that will compile into a working shader, right? But there's, like, you know, you have to do all the back-end stuff. And that's like the annoying part. Okay. How are things with the compilation time? At the start, you said compilation speed would be very high. Was it 1 million lines per second? Is it still viable? Are there any unforeseen obstacles? Okay, so yeah, the compile target for a while, it actually, the compile target originally was lower, and then we blew past that, so I set it at 1 million lines per second, which is still the target. We have not really worked on performance to hit that target yet, because like the thing is always, the model we're operating under is that the way that other languages that are using, there's this whole compilation paradigm that's been the foundation of these operating systems since like the late 60s, which is you compile out some object files and then you link the object files, right? And then that's how you get parallelism, supposedly, right? But that's not right because these compilers are so slow. So obviously they're not really achieving efficient use of the CPUs. So what's going on? And there's always this trap where, not just in compilers, but in everything, like in the web or whatever, where people do a ton of really slow stuff and then they're able to do that in parallel and they think they're winning when like they're losing by 2 orders of magnitude, right? So that's just like the state of the current idea that everybody is following to do stuff, is they're doing these very, very slow, inefficient things to get parallelism. And now, to be fair, though, it's a little bit more scary to do parallelism the actual efficient way, which is in your process to do things in parallel, right? The reason that people want to compile object files and link them is that each individual process doesn't have to be very parallel, because that's harder. But like part of the reason it's harder is because our programming languages have not actually given us help with that. And parallel for does not count because that's not the hard part. In fact, parallel for is not a good way to do parallelism anyway. The hard part is correctness and knowing when you did something wrong, right? Now, again, there are languages like Rust that try to help a lot with correctness. And on the one hand, that's helpful. On the other hand, it's very, very, very draconian what constraints you need to comply with to get that correctness. And so I don't think that that's good. So there's this question of like, how do you ensure correctness, right? Stuff like thread sanitizer helps, but you would rather have compile time static checking for correctness. And that's actually one of the things that we continually think about is how can we provide more of those mechanisms in a low friction way as opposed to a high friction way, the way some languages do. Now, even if we had those ideas, the compiler is in C++, and so we wouldn't get the benefit of them. So parallelism is still like, it's on the roadmap, but it's further on the roadmap is sort of what I'm saying than some of these other things we've been talking about. The compilation speed right now, I just tried it before the stream. It would be a little slower because we're streaming, but it's, if you don't count the linker, of course, it's 180,000 lines per second, which is on this laptop, which is not the fastest that we've been. The peak compiler speed was around 270,000 lines per second on, a machine from 2 years ago or something. Since then, what happened is I made some architectural changes that I thought would go faster. They did not go faster. In fact, they went slower. And so it's sort of been on the roadmap to maybe reverse those decisions. But it's always not that straightforward because it's like, okay, maybe we made a dumb bug in the new thing and we can just fix that and it'll go faster. Maybe just some elbow grease will make the new thing go faster. The deal is the old thing used more of a data footprint when doing type inference, and the new thing is much more compact. The problem is, I think the new thing also just does a lot more unpredictable branches or something. Like, it's not good. Or, again, maybe there's a bug and we're doing redundant work. And it's just not clear because we haven't spent that much time optimizing, right? But, So we took a speed hit there. We've sped up other things though. So like the speed hit we took was like heavy. It was like 40%. But then, we optimized some other things, so we're not down that low. But the goal is to at least, so with the single-threaded type checking that we have now, to at least get that back, to get back above 250,000 lines per second. That's provably accomplishable because we were there already, right? And then once you're there, it's only a factor of 4 to get 1 million lines per second. Can you get a factor of 4 parallelism? I think so. Like this laptop, or this one, I don't remember. This one has like 16 cores. The other laptop that I'm not using right now, except to read the questions, I think is like 32 cores. It's a lot of cores, and some of those are efficiency cores. But there's just like, if you're able to parallelize, there's just a lot you can do there. The thing is, given the tools that we have, that parallelization is difficult, and it does require a sufficient re-architecting. However, okay, so there's one other thing, which is there's a sort of an invisible parameter of code. Parameter is maybe not the right word, but it's like how easy is it to make architectural changes to this code to try things out or to do what you need? And for this compiler, the answer has often been pretty hard because there were a lot of, just the nature of a programming language is you want features to interoperate. And so they tangle together in a certain way. Like they all intersect with each other. And well, sometimes when you first implement features, it's not clear how to do any better about that, how to make them cleaner and more orthogonal. But sometimes, even just after getting some time thinking, like calendar time thinking about it or whatever, you can go back and be like, oh, if we do this other thing, these two things will be more orthogonal relative to each other. They won't be so tangled together. So now we could change this one or change this one, and it's not so heavyweight. Like the problem is, for example, with this thing that I said, where I made the architectural change and it went slow, it's like backing out that change would have taken a week, which is a long time. And I was like, I'd really rather try to carry it forward and stuff. And the reason backing out that change would have taken a week is because there were all sorts of dependencies on like what exactly are the data structures and how things are stored and how you search for, like how you know if you're in a certain situation, which other constructs in the language want to know, right? And that stuff gets gnarly, right? But we have made a number of significant architectural improvements internally to the compiler where those things are more decoupled. So now if I were to try to back out that change, it wouldn't take a week. I think we could probably do it in like 2 days or 3 days. And that makes it more appealing of an option, right? That it takes less than half the time. And it's also not just that it's a week. It's like it would be a very painful, miserable week full of exactly the kind of debugging that I hate and makes me sad, right? Whereas now it's like, okay, it's probably a much cleaner thing that would be more like, feel more like going forward. So that's the state of all that. Hopefully that makes sense. I realize that was a bit rambly. Okay. Reminder to Twitch chat people, I'm not reading Twitch chat yet. We're in a different chat. We may go to Twitch chat if we have time at the end. Okay. But okay, so I just got done talking about all these problems. But like the compilation speed is still pretty fast, right? Like we're even using a bunch of our cores to compress right now, or to compress video because we're streaming. And like we built our 250,000 line game in, 1.36 seconds. That would be a little bit faster if we were streaming, right? It's just, the game's gotten a little bit bigger, but at some point a little more than a year ago, we were at like, this number was 0.7 seconds, right? So we're not, you know, we're faster than basically everyone else's modern compiler that I'm aware of by a lot, but we're not as fast as we could be. We could be, you know, well, the target again is, you know, this is about 180,000 lines per second. Maybe this is 200, right? So if I just go, you know, 260,280 divided by 1.36 is, it's 190, right? So we're a factor of 5 point something off the eventual target speed, which is easy. Like, yes, we can speed this compiler up by 5x, no problem. Well, problem, but it is certainly possible. And that's one of the things I want to do. I spoke in answer to a previous question about scaling a little bit. If we have more of an actual team working on the compiler, we can do stuff like this a little bit better, I hope. If those people are good, which is going to be important. What are some principles you have in mind for implementing an optimization pass for the compiler? What do I think C++ compilers do right, wrong about code optimization? Okay, I feel like there's a video about this somewhere, so I don't want to go too far into it, but basically, like, the idea, the whole paradigm that compilers are operating in is for a certain kind of customer in quotes. And that customer is someone who doesn't understand their code that much, believes the compiler is better than them at optimizing, and just wants the compiler to make their code go fast, right? And that's fine. You can get a certain amount of mileage out of that. But it leads to the compiler doing all sorts of just nutty, heroic optimizations that can be unintuitive and then often go wrong and like actually make your code slower. Like Casey's complained about that a few times. Or are just hard to understand or introduce bugs and so forth, right? So our picture is different, right? In the world that I live in, programmers are way better than compilers at making code go fast algorithmically. Like, you know, if your game engine isn't running that fast, a good programmer can speed it up by 10 times or 20 times or 50 times, right? Compiler can't do that. So, but the compiler, what the compiler is very good at is things that would drown you in tedium because the quantity is so high, right? Like, hey, we're doing all these little optimizations, but we're doing so many of them every time you hit compile that you would just go crazy and die if you try to do all those by hand, right? So that's the job of the compiler. The job of the compiler is not, okay, so there's a certain philosophical thing that I've seen posted around the compiler community, and it's very diluted, right? And this idea is the job of the optimizer in the compiler is to map your program into the fastest possible program that will perform the same output. And that's just fucking nuts. It's fine as an aspirational statement, but if you actually take that seriously, you're not going to do a good job because you can't do that. People can't even do that, right? The compiler is very far from being able to do that. But the way we see it is the job of the compiler is to perform a dependable set of operations that are very helpful in terms of speed, that are also very understandable by the programmer and are very consistent, that like don't flakily occur or not occur depending on very esoteric things that may change from from compilation to compilation, right? Which is how most optimizers are. And so that's just a different set of stuff. And in fact, rather than optimizing certain kinds of code, we might just say, hey, this code looks really slow, you know, please change it. Like, you know, compilers do a ton of work to like, you know, lift code out of loops and stuff, which is fine. Like that helps a computer go faster, but like, why you got that code nested 3 loops down anyway? What are you doing, right? And there's a lot of times when compilers won't be able to lift that code out because like it's not sure if there's side effects or something, right? And so it would actually be really useful for the compiler to say, you know, it looks like there's a lot of code down in this loop that like almost we could lift out, but we're not sure. If you could please take a look at that and move it, that would be better because it would help everybody who reads the code understand that that doesn't need to be evaluated. Like there's a code understandability element there, right? Which is part of why I'm saying this philosophy that people use about optimization is kind of nuts. And it also like, again, that fastest possible program that does the thing, it's what leads people to do a lot of the UB craziness that is infected everybody. I don't know. But anyway, that's enough of a rant. It's not a particularly coherent rant. If I were to give an organized thought about speech about this, I would express it much better. Yeah. Okay. What's the most useful feedback we can give you as beta testers? You know, I don't know. Syntax suggestions is my least favorite. And so that's why there's a syntax suggestions channel, because I can only read it when I'm in the mood. But like really, like if people are working on actual hard problems, like building software that is complicated, and we can just see how the compiler does that and what we can do to make that help. Because again, so very often, in fact, almost all the time when somebody designs a programming language, they design it based on things that look cool that the language could do, which are usually very obvious things that don't help with the hard problems. Like they usually help with the easy problems. Hey, we're going to have some cool array syntax where you could, in the middle of an array, have a number and then ... 7, and it repeats that number 7 times or whatever. And it's like, okay, if you want to do that, I mean, cool, but like that doesn't really help me. Like if I list all the things that have been difficult during game development and have almost killed the projects that I've worked on, none of them are that when I put an item 7 times in an array that I had to write it 7 times. Like that's so far off. In fact, it's not even on the list because I would rather see the numbers than be confused about what's there. But that's the kind of thinking that usually drives programming language design, right? Very few languages are designed based on what are the actual hard problems and how do we address the actual hard problems. And the reason is because, again, you know, not to get too elitist about it, this is not really just by statistics, by numbers, most people who get into programming have less time on it because they're less experienced, so they're doing less complicated things, right? You need to have a certain experience level to even be trying to do hard problems. Well, that's not true, but to be doing a competent job at solving hard problems, you need some experience, right? I mean, the problem is if you're not experienced, you might think something's hard and it's actually not hard. In fact, that's most of like the web world and stuff, right? There's people who think trivial things are hard. Anyway, so it's just like, it would be hard enough if we weren't drowning in this garbage of like, very confused ideas about what is good in software or even how fast computers are. Again, like there's all these people who have all these opinions about computers and they don't even know within 3 orders of magnitude how fast their computer is, right? So it's just very confusing. And so what we're trying to do is just break through the confusion, encourage some people to be working on advanced, difficult things, and then we're aiming our design effort at the advanced, difficult things. to try to extend the ramp, right? There's this question of like how, if you just start out with a blank file and either yourself or a team that communicates effectively, and you start typing code to do whatever the most advanced thing is in your problem space. In the beginning, it goes very fast, and then it starts slowing down, and then it slows down even more, and then eventually it's a fight to get anything done. And then eventually you like pass some kind of peak and things start decaying. And that's what happens to every single software project. Now, how high is that peak? And can we extend the height of that peak and possibly even make it so it's more like you level off instead of decay, right? Can we make it much more of a gentle so that you can get more high at a gentler slope before you level off? Like, those are the things I'm worried about, right? And that has very little to do with obvious syntax language features like most people focus on, right? And so that's why also a lot of people look what I'm doing and don't, like, it doesn't make as much sense to them. It's because a lot of the reasons behind why things are the way they are not exactly buried, but like you have to look way down the line of like what are the hard problems in order to see the justification for the thing. All right. So anyway, that's enough on that topic, I think. Again, I have to apologize, by the way. My explanatory brain is not ticking in top form today. Some days I wake up and that part is sharp, and some days it's sleeping. And today it's sleeping. So I think my explanations are not as good as they often are. But that's where we're at this morning. All right. What would you consider technical problems, unknowns that someone should be aware of if they wanted to ship some production-ready software today? I think the main thing is, again, if you want to have some like DLL plugin architecture, you need to be a little bit aware of the status of context and type info across DLLs. That's something where we made improvements a month or two ago, and we're looking to continue to make improvements, and eventually we would like it to be streamlined and perfect. But in the meantime, it's like, okay, that's a thing to think about. And then the other thing is, again, cross-compiling is still, it's still in early stages. It at least is possible now to cross-compile. Like, you had to kind of, if you go back a month or two ago, you kind of had to hack a bunch of the core compiler files to cross-compile it all. And then you were subject to a lot of constraints. Now, so for example, Raphael did some stuff in the past couple weeks to at least remove that hackery. So now, for example, we're able to cross-compile for the PlayStation 5. The problem is just because we're early in enabling that, your run directives might mess you up. So the problem right now, okay, so to state the problem statement, right? Let's say you've got some file module that loads files, right? That has different implementations on different operating systems, right? On Windows, it's going to call, create file or whatever, and on PlayStation, it's going to use the way better, more modern file API. Well, what happens when you're cross-compiling? Well, your executable needs to use the version of that for the target operating system, which in this case might be PS5, right? But if you say you have a run directive that just wants to run some code at compile time to load a file, that run directive has to use the Windows version if you're compiling on Windows, right? And so the challenge is to disambiguate that and make it work without, at the same time, making it super tedious and horrible to write programs, right? And so that's the line that we're trying to thread. Like, if you're not cross-compiling, which is most people most of the time, we just want it to be easy and just work, right? And then if you are cross-compiling, maybe you have to think about a little bit more or be subject to more constraints, but I don't think those constraints should be too onerous. Like, I think they should be things that just work. And so, yeah, that's the current state of that. There were a few questions about pointer aliasing. Will keywords directives be introduced? Or will this mostly be tackled by the structure of the program as seen by the compiler? Okay. Yeah, aliasing, definitely an issue in programs, for sure. I don't want to, there's probably a lot of people here don't know exactly what that is. It's a long discussion, so you could look it up. But basically, aliasing is a situation that happens with pointers that can cause your code not to be very optimizable, right? Or maybe your code is optimizable, but the compiler can't figure it out. Let's put it that way, right? And my status on that has always been obviously a thing that we care about. We can introduce features for it, but I never want to just dive in. Like, one thing you could always do is just dive in and say, okay, we want to do this and that and that. Let's just make features for this and that, and there we go. And the thing about that is it's often the way to, well, there's two problems. One is that's often the way to make a language more complicated than it needs to be. Because instead of just making 3 separate features to do these things, maybe you can figure out some language semantics that do a certain portion of that automatically, and then you only need like 1 feature over here. It's a way of keeping complexity down, right? And then the second thing is, the other trap is, it's always, well, how do you solve this problem? Well, we have examples of C solving this problem in a certain way, so let's just do that. We know that that works to a certain extent. And if that's the way you make all your decisions, you just end up with a trivially syntactically different version of the same language that you're copying, right? Now, at the same time, you don't want to be ignorant of what people have done, or not draw influence from that when the influence would be beneficial. So again, it's a fine line to walk. Certainly this language has drawn influence from a lot of other programming languages, like undeniably. So, well, that's the background. And so it's a way of explaining, I've just sort of been, dragging my feet on adding a straightforward no alias keyword because there just might be better things to do. That's all. And one of the language semantics we added is the maybe by value calling convention, which means that if you pass something, by value / reference, that's like automatically no aliased, but in a cleaner way, because the compiler also can know that, like, if it gets modified out of turn, it's pretty easy for the compiler to detect that. Now, at the same time, that also could happen with a no alias keyword. Yeah, I don't know. It's just always like we're taking our time to figure out a really good solution for it. That said, if we had conclusive evidence that there were speed problems due to aliasing that were getting in our way or getting in the way of, beta users doing complicated things, we would bump that up on the priority list. Just because we could also just do a dumb no alias keyword for now and then think about it and see if we can come up with something better, right? That is just, that is also a tactic that I've been perfectly happy to employ both in games and programming languages. The only thing is just, it introduces the temptation to just be lazy and fall back on the thing. And so I don't prefer to do things that way sometimes. Okay. Could you do a bit of a steelman for Raylib, SDL, and OpenGL to show how and where SIMP fits in and how it's easy to switch between all of these? I have to talk about how easy it is to render. People are just unaware that things like Raylib, SIMP, etc. even exist or a path that you could even take. Yeah, okay, so here's, I don't want to go too much into this because it's actually a big question that could go on for quite a long time, and we're already 50 minutes into the stream. But, okay, in general, us being a programming language, our job is to support whatever people want to use, right? So some people might like Raylib, some people might like SDL, some people might want to program to OpenGL themselves, right? So firstly, our job is not to compete with any of that, right? Okay, that said, at the same time, the reason that SIMP exists, for example, I had not seen Raylib, and in fact, I still haven't. I don't know what it looks like to program in Raylib, right? But I've seen SDL. I've certainly done OpenGL directly and all these things, right? And I've always been very unhappy with how complicated it is and how much code you have to write just to do basic stuff in all these other systems. And so that was what SIMP is for, is to give, so firstly, to give people who want to use this language a maximally simple way to just start putting things on the screen. But also, and this is where things get a little interesting, right? Part of the job there is to see how the language features can make it simpler and easier just to make a program that draws stuff on the screen, but also as a test, right? Like if we can't make a really simple system for putting stuff on the screen with interchangeable backends and all that stuff, maybe the language features aren't as good as we thought they were, right? So it's also a test of the language. So that's what SIMP is. I like SIMP so far. It has two big limitations. One is there's no SIMP 3D, right? And two is it's very limited in terms of what, graphical effects you can do. Extremely limited by design. So already, of course, there's just different use cases for all these things. I do wish people understood how easy it can be to the second part of your question. Yeah, like if you're working with, like the problem for decades, this even goes back to like MFC and like XLib and all these ways of putting buttons on the screen and stuff. Like everybody always felt like it's okay if it's fucking rocket science to put buttons on the screen and have them sized correctly. Like it's fine if that's 100 lines of code because it's for some reason supposed to be hard because it's computers. And it's like, what are you talking about? Like, like if you can write down the sentence, put a button here that's this color with this text, like it shouldn't take that much more code than that sentence because there's a certain amount of information in that sentence, right? Like, why does it take reams and reams of code or like tons of if statements or like calling things at 3 different times? Like all of that is obviously a failure mode, right? Because as a programmer, you should just be able to say what you're trying to say. And so, yeah, but I think over time we've been seeing improvements in that kind of a thing, and people are starting to wake up to the fact. And I think some of that took competition from these other really slow, terrible systems, like some of the stuff in JavaScript. But as bad as the JavaScript stuff is, at least you can do things in a small number of lines of code, right? And the place where people get confused is they think, oh, that's because of JavaScript. In C++, you have to have a ton of lines of code or something. And it's like, no, it's just the API. You could have a cleaner, better API in C++ as well. It's just for decades, nobody did that because everybody was in a cognitive trap, right? And so that's all. That all is what it is. I mean, there is, so of course, you know, the fact that JavaScript garbage collects and stuff does give you a little bit of programming convenience. But one of the theses behind this language is that that's not as much convenience as people think, right? Anyway, so all of that is just a way of saying, yeah, I mean, in terms of the user level code in this language, one of the things we're trying to do is make it easy to do stuff even though you're in a systems language. And to not exactly dispel, because that's the wrong attitude, like dispel the notion that people have that systems languages are super hard. Because there are things like, yeah, you can do memory bugs and stuff, right? And that's a thing that you deal with. But like, it's not nearly as hard as people think it is, because they've been using systems that have both. It's like, okay, it's a systems language, so you have to think about the systems language things, but it also gives you no help with those system language things, which is horrible. And in fact, old style C was like almost actively, aggressively fuck youing you all the time. And just the APIs were not designed by people who seem to care. Like, programmers were just brain dead in a certain way for a long time, and still are a lot of the time. And we can just give an example of, here's us doing our best not to be brain dead. I'm sure we still are in certain ways, but look, let's just make it simple in certain ways as much as we can. And so that's part of what that's for. Okay, way too long of an answer. Way too long of an answer. Regarding backends, do you plan on supporting metaprogram supplied hints for program optimization? Example, block is unreachable, values have ranges of blah, 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 pointer argument is never null. I don't know about those exact hints, but yes. I do think, so let's pick a simple one like optimization level. So we, you know, just in a recent beta, we changed what are the settings for how you specify optimization level. Because right now the LLVM is the optimizing backend, and you should just be able to say exactly what that backend should do. But right now, so, you know, and those settings in LLVM are pretty traditional. They're the kind that have been around for decades, like optimize for size, optimize really hard for size, optimize for speed, optimize really hard for speed, right? And those two things tend to work against each other, right? And very few people, you know, as a result, use optimize for size, except if you're on an embedded system or something. And so if you're on Windows or, you know, Mac OS or PS5 or whatever, the natural outcome is a giant ass program, right? And the thing is, you probably didn't need to, so, you know, and the reason that happens is because optimize for speed often does loop unrolling and all these things, which, by the way, loop unrolling does not help as much as it used to, because CPUs are much, much better at branch prediction now. And so I think compilers are overly aggressive when it comes to things like loop unrolling for the year 2023, right? But whatever. The result is you blow up the size of the code in the hope of it running faster. And, you know, you could have a metaprogram. Let's just say, even if you only had those settings, like how hard like either optimize for size or speed or just debug info, right? Your metaprogram could just say on a per function basis who gets which of those. And that would actually be very helpful in keeping your program small, right? And in fact, okay, what's one common problem? Well, we have a release executable and we have some bug in it, and then when we compile in debug, it's like so slow, it's annoying to debug, or we can't exactly repro the problem, but we want to be able to break in this function and do stuff, right? Well, just compile the whole thing in release except a couple functions in debug. Why not do that? And the answer is just because usually you don't get that flexibility, right? And so providing people with that level of flexibility, I think, would be good. And then as for other hints about per variable hints and stuff, I think once we start building up more of a modern optimization framework, we might have more of an opinion about what those things could be. But at this time, I don't exactly know what would be good hints. I mean, aside from no alias again, right? Like no alias, I know how that's useful. Other hints, like this is the range of this variable, I don't, like, it's just not that useful most of the time. How much of a productivity benefit do I think the language has given us working on Sokoban as compared to Witness or Braid? I mean, negative a lot because I had to build the compiler, right? And we still work on the compiler a lot. But if you factor that out, I don't know how to quantify. I just like programming in this way more than C++. I do get things done a lot faster. That said, I'm also a more experienced programmer than I was in the C++ days, so you can't just, there's non-orthogonal factors there. I don't know. Like, I don't want to get in this weird thing where I make up all these numbers and then try to sell the language to people based on these numbers. I would like to make the language. If people enjoy programming in it and they see that they get things done faster, that's great. That's what I'm trying to do. The problem is, as soon as you try to objectively measure things, everybody starts gaming those measurements and it sucks. But that's a problem because, on the other hand, that's the only way you really know that you're right, is with objective measurements. And we just, even though software is supposedly an objective domain, we're very bad at being objective. And so I don't, again, if I weren't doing all this other stuff, I might actually try to solve that problem. But we've just got too much going on. And so we only can fight so many battles, so we're keeping it restricted. Regarding blocks that return values, for example, those from ifx, can they be made more general? Yeah, I don't want to go too much into this one because it's kind of a syntax suggestion. So you can look at the functional style languages to see languages where every block returns a value, etc. Could we do that? Yes. Is it worth it? Maybe. Like, there are a couple of cases, for example, if you want to initialize a variable inside the block, assigning it to the value of that block. Yeah, it's always a question of, is it worth the amount of extra cumbersomeness added to the language? And so where I would say that is it's on the roadmap still to think about it. Definitely internally, we have blocks that return values. What we don't have is syntax for you to use those at any time, right? And it's just, should we add that? Maybe, right? It's just not a super high priority. Like, all this other stuff we're doing is higher priority, like enabling cross-compiling, enabling DLLs to work better. All that stuff is higher priority. You've seen some examples use import inside the function scope without naming it. You were surprised that unnamed import is visible outside the scope. Is there some reasoning for that? Yeah, I mean, we might change this eventually, but import just operates on your program's module scope. Like, it's not only like locally scoped to a function. I have this file up the whole time and it has nothing to do with anything we're talking about. So anyway, it also ignores file versus module scope, right? And that's just the way import works. And might we change that? Maybe. But the thing is, you already have the flexibility to change that if you want, right? You can bind a name to the import and then using that name, and it'll pull it only into the scope of the function. So because you can do both the way it is now, it doesn't really need to be changed much, right? It's more a question of like what's clean as opposed to what can you do. Have I decided if closures should be part of the language? Again, we could do it. It's just low priority. I don't, closures are annoying because they introduce complexity. And so, again, on the roadmap, we have a roadmap to closures that's more like, make function pointers be able to be more like strings where there's a data and a procedure pointer in a 16-byte thing. And then once we have that data pointer could point at closure data. It's just, it doesn't matter that much for anything realistic that we're working on. Like, again, if you find yourself wanting to do a bunch of closures because you learned from the Abelson and Sussman book or whatever, it's like, okay, but that's just not really what fast code looks like. Don't know what to tell you. Or not even fast. I mean, yes, fast, but also that's not really what understandable code looks like. Understandable code doesn't look like a closure with a bunch of local variables exactly at different levels of nesting and all. Like, yeah. So it's just not been a priority. That doesn't mean we won't do it. It just means, again, there's things that are more important in the short term. Okay. Are there any plans for there to be something like metaprogram plugin, but for modules? So modules can define how they hook into default metaprogram. The metaprogram plugin API seems like a perfect fit. But right now it's only for metaprogram plugins that you plug in at the command line. Without something like this for modules, module authors provide procs for the module user to call in their own metaprogram. Yeah, okay, so yes, so this has been something that I've been vaguely thinking about since the language started. And I sort of just decided to punt on it for a long time because it wasn't totally necessary. And we would see how everything else shakes out. So the deal is basically the following. If you import a module, well, usually what you're doing is just like if you included a library header file in C++ or whatever. This chair is really uncomfortable all of a sudden. I need to get better chairs here. I'm using these pre-supplied chairs in this apartment, and they're no good. I need my chair from Florida. Actually, I have one in the office in Denver. Dang it. Anyway, okay. So the most basic thing you could be doing is just using the code at runtime, just like you would expect. But if the module's sophisticated, it may want to do something at compilation time, right? And then how does the metaprogram do it? And yeah, so the metaprogram plugin, what that does is it provides a way of, there's certain hooks at various times during compilation. That plugin has function pointers that can get called at those times, etc. And so so if we want to talk about, okay, well, we don't want to put plugins at the command line. It's just when you import something, I want stuff to happen at compile time. Should that happen automatically? Or maybe it shouldn't. I mean, this is another thing, right? Maybe we just shouldn't be trying to be that magical. I don't know. Like, there's this question, if you give people that ability, do they just automatically abuse it and then everything is bad and confusing and slow? I don't know. But it's worth thinking about at least, right? And so that metaprogram plugin structure, I think, is basically what you would want. It's just there would need to be a way for a module to say, hey, please plug this in. Now, there's no syntax for that, but actually more important, it doesn't work right now with certain features. Because after you've decided to import a module, if it's inside a static if, or if the import came from adding a string or whatever, you're already at the point of compilation where the context got finalized. But then very often you want to add context in these more complicated scenarios. So that's actually, in fact, if you try to do a thing where you add a plugin not in exactly the way that the default metaprogram does it, if you try to add the plugin later, you can't do it if it adds to the context, right? And so that's actually a thing that I want to solve. There's a plan for that. It's not even very hard to do. It's just, you know, one of the things that we would have to do to enable that. So once we enable that, then there's not really a technical roadblock to that kind of thing anymore. And then we could decide if we actually want to make it happen. Is the x64 backend planned to remain relatively unoptimized but fast to compile, or planning to make it more optimized in the future? We are planning to make it a fully optimizing backend eventually. But I mean, that's a little bit of a misleading way to say it, I guess, because the majority of the optimizations would happen in the bytecode, and so would apply to any backend. For example, you could imagine an ARM backend or whatever that we would make. Yes, the answer is to do more optimizations, but also, again, like in the same way that we already compile 10 times, 100 times faster than a lot of compilers, that will extend to optimization. So if we optimize, it will be slower than what we do right now, but it'll be a lot faster than what everyone else is doing, because there's no excuse for how slow everybody else is, right? So it'll be slower than the debug build right now. Actually, in the end, it might be faster because we'll speed up the rest of the compiler, but it'll be slower, but it'll be faster than you're used to from other languages. And that's one of the reasons why we kind of can't, like, again, my stance that I keep telling people about the LLVM backend, it's very useful and helpful. It does very good work for us right now. At the same time, we simply can't say that it's a core part of the compiler that we design for you to use indefinitely into the future, because it keeps getting slower. Like right now, it takes 3 minutes to optimize Sokoban in a release build. Like, why? It's a, let's do the math on this, right? So it's 175,000 lines of non-comment, right? Okay, 3 minutes, 175,000 lines, divided by 180 seconds, right? So it could do 1,000 lines of code per second. You can decide for yourself where that falls along the slow to fast spectrum. Right? Yeah, 1 millisecond per line of code is how fast it can go. You know, per core, I guess. But yeah, one thing I would like to do, you know, I've got a bunch of stuff I need to do that's other than this in the near future, but every once in a while, to break a little bit of ice on something new, I like to spend a day or two just pushing the boundary forward on something. And the glimmer in the back of my mind is I'd like to just spend a weekend or a few days during the week just putting in some basic bytecode optimizations and just to get that started, you know. Because the thing about optimizing is it's really a never-ending thing because you can always have different ideas about what optimizations you should do, right? But like just getting it started a little bit. And in fact, you know, we already did a bunch of stuff. So actually, Raphael from the newest beta fixed some of the bugs in basic block computations, which, you know, if those are wrong, your optimizations will come out wrong. So it's good that we found those, but you know, that actually, the addition of all the basic block stuff was the first step in like, okay, let's make this look like an optimizing compiler. Next step might be SSA. Because again, contrary to the way most people do it, SSA generation is actually kind of trivial. For a long time, I wasn't sure if we were going to do SSA, but I feel like now it's probably the right move. So, yeah, we'll see. When doing named imports, operator overloads do not seem to work for structs defined in that named module. And you understand why one would want that. That just seems like an oversight or a bug. So I would report that if I were you, and we will fix it. Because there shouldn't be any difference between that, between referencing through the name and not. Are notes on inner scope blocks planned? I mean, in general, it would be a nice thing to have notes in a broader variety of places. The question is just, how do you do that and also make it legible to people's metaprogram, right? And like useful and like that they don't have to search everywhere for notes. That's just the question. I am processing polymorphic procedures through a metaprogram type-checked messages for a language server, and you've encountered a problem because the body of the polymorphic procedure is not being sent. Only the resolved polymorphic versions are being sent, which is logical, but the problem is we don't get any body for polymorphic procedures that are not being used. So we can't process the procedure body block, so we can't provide go-tos, etc. until it's used at least once. Is that something that can be changed in the future? Yeah, I mean, for sure. For sure we should do that. The question, like, it's a little bit less efficient, right, to just do that for every polymorphic procedure, but maybe not, because like you should be calling it a lot more than once, or else why is it polymorphic? Like with different types, I mean. So maybe it's not that much extra message load to always send it. Because there's this question: do you always send it, or do you add some flags that people use? That the problem with that is it adds complexity, and people have to know about those flags, and it's error prone and all that, right? So maybe we send it always. The reason I wasn't doing that originally is the following. Because if your assumption is that most code you get is type checked, then you know the type slot of any node is guaranteed to be non-null, I think. And you know, you might crash if you thought something was supposed to be non-null and it's null, right? That's the classic crash. Now, polymorphic procedures, of course, can't have their bodies inferred because we don't know what type anything is. That's the whole point. So we would have to be sending this thing in with all these nulls, but maybe that's fine. Maybe that's just what it is, and we solve that some different way. You know, all the people who like other languages are like, make non-nullable pointers. And, you know, we might do that eventually, but again, that's one of those features that I'm not sure is worth the hassle. But yeah, email that one to the email address so that we get it officially on the list. But that should be like, as a matter of general principle, you should be able to round trip a program from your meta program and just compile. You should be able to cross compile it into C or whatever from your meta program, right? If you can't do that, we need to fix something. Now, the question that I have, there could be two reasons why you're not getting that procedure body. One is we have some if statements to filter out polymorphic stuff from the messaging system, like in the compiler, and it could just be that. It could also be dead code elimination. So I would just say, if you haven't, maybe you've tried it, but try running with, you know, dead code elimination off. And if that doesn't fix it, yeah, definitely email us and we should fix that. What is your policy for accepting big changes to parts of the modules distribution that you yourself barely use? Specifically, people are working on Wayland backend for input windowing and simp. Would you be up for shipping it together with the compiler alongside X11, or would you rather have backends that you won't be targeting? Okay, so I don't want to ship everything in the modules folder, right? I would like it if people out in the world have their own modules to do stuff. However, when it comes to basic stuff like this, the job of which is to provide operability on different operating systems, it's sort of the job of these standard modules that we are providing to do that. And so, yeah, like Wayland compatibility, like it saddens me that there's like literally still Wayland and X11 running on Linux and you have to frickin' support both because that's stupid, but that's where we're at. We're in a world where nobody ever makes anything simpler. So yeah, we would ship that at some point. So yeah, we would take contributions for that as well. Sometimes we get contributions that make us sad. So don't give us contributions that will make us sad. Same question could be asked about Vulkan or Metal backend for simp. Yeah, that would be a good idea. Like, if someone wants to do another backend for simp, that would actually be great because it's like simp is supposed to be backend agnostic. So this would be a test of like, how well is that working, right? So for the modules that are already there, yeah, we would expand those in those ways. But also we want to be careful because here's the thing. If we're not actively testing this stuff and running it all the time, then problems can creep in, right? And so, and we don't want to be giving out a module folder full of things that don't really work. So what I would say is I would try adding these things. If it turned into this situation where we're giving out a modules folder full of things that don't really work, well, we would try to upscale our processes to handle that. Whether that means, so for example, we have a test suite that runs and makes sure things compiled, but we don't like run X11 client programs on a graphical Linux machine in the script to make sure they don't like X bad pipe fault or whatever, right? Like we don't do that stuff. So certain kind of problems can creep in right now that we wouldn't detect. And so maybe we would just try harder on that stuff. But at some point, see, that's a trade-off between working on the actual compiler and doing that stuff. And at some point, if it gets too hairy, we would just say, well, let's keep the modules down for now. Like, I don't want the size of the modules distributed with the compiler to be massively bigger than it is now. Like, I feel like, in fact, maybe we should take a few of the modules out. Because people shouldn't be afraid of the code that comes with the compiler, that everything is running on top of. It shouldn't be a giant maze that everybody is scared of like glibc and stuff, right? It should be clean and simple and understandable and enjoyable to look at. And it should give you this feeling that programmers used to have of like, I'm really understanding and mastering this system by looking at this source code, right? And, you know, the more stuff you add and the more complicated it gets and the more the quality declines, the less you have that. And so that's the idea there. Okay. Is there something about the compiler that I would change if I would start from scratch, but that is too hard to change in the current state? I don't, not exactly. Like there's definitely things that I did. This happens in games too. There's design decisions that I made that were not right initially that caused a lot of pain and then eventually were changed. But usually once I figure those out, I actually make the change. Like there's things in this compiler that have been rewritten 5 times. Like the entire system's been rewritten 5 times, right? Less so lately, although the for loop stuff, I just rewrote a significant chunk of that. Like all the macros and targeting and all that a month ago or whenever. That was like the last thing where I was like, this shouldn't be this hard. Why is it so crazy and complicated and incorrect and causing bugs? And yeah, that's one of those things that I rewrote. In terms of the architecture now, I don't think there's anything that's too hard to change. Like I do, like if something becomes too hard to change, your software is dying already, right? So what I would say is, what would I look at to try to simplify? The current things that come to mind are just all the stuff involved in type inference is a little too complicated and there's a few too many things like flattening and then go live and then the inference loop. It's just like too many things, and I wish I could make it fewer things, but there's also reasons why it is what it is. I feel like it could be simplified a fair bit. Like flatten and go live are kind of the same thing, except in some cases they're not. Like, so yeah, there's stuff like that. But no, I mean, I've definitely dove in and rewrote stuff. There's going to be a little bit of a moratorium, you know, in the next few months on me doing large-scale rewrites like that. But that doesn't mean they're off the table completely. It just means I can't do them until, you know, September or something. How does resolving dependencies on identifiers work right now in the compiler, considering an identifier can pop up at any time in the compilation because of compile time execution? Okay, this is one of the things that is more complicated than I would like. And there is a simplification that we could do, actually. And if Raphael wanted to look at this, because he asked that previous question. This is like a language semantic change that might, if we made it, it might just be better for everybody. It might make compilation cleaner in terms of error messages, and it might make the compiler go faster, okay? And that is the following. Right now, it is legal to use an identifier that's not declared, that might get declared later, and you can just use it, right? Because there was this picture the whole time of like compile time execution, adding strings and all this stuff, right? Also, this is the way imports work, right? So like if you use cosine and the math module hasn't been imported yet, because we're compiling out of order compared to how C++ or whatever does, we run into the call to cosine before the import is done. That's quite likely, right? So I'm getting a little chocolate for the throat here. Internally to the compiler, this adds complexity because identifier lookup might have to yield if it's not defined yet. And we might spend some time spinning and yielding and stuff. And there's also just more if statements than I would like and all that. However, I think it's clear to me there's a reasonable possibility that we could enforce a stronger language semantic, right? Which is the following. it's not legal to use any identifier that isn't currently defined. So if you're going to generate code that uses an identifier, that you're going to insert code to define, you could use the placeholder construct, which we've added a long time ago. And then the compiler knows that that's not really an undeclared identifier, right? Or, you know, if there's imports that haven't completed or whatever, then we know that, right? We know if, so an import could be, it's a little complicated, an import could be in a static if, so you check the static if and see, right? And then there would be certain, so we just got done mentioning earlier that you could have an import that is like in a polymorphic function or a struct that doesn't get instantiated till later that applies to the global namespace. And we would have to decide in cases like that if that's legal or if you would have to use a placeholder. But so that's the question, is like, how much friction does it add to say you can't use an undeclared identifier? And then if we do that, I think the code becomes simpler and error messages for users might become simpler and better. So that's the thing. Okay, so but to answer the question of how does it work right now, literally what the compiler does is if there's an undeclared identifier, it says, I'll come back and try this later after we've made more progress compiling the program, right? And then it keeps doing that. And at some point, if there's no definition for this identifier and no more progress can be made compiling the program, it reports undeclared identifiers, right? Because of that, you would think that reporting undeclared identifiers in a programming language is a very simple thing, but in this language, because of that, it's actually pretty complicated and a little bit error prone. Like when there's a little bit of bugginess in the compiler or whatever, it could result in very unhelpful error messages. Or not correctly declaring that your problem is just a frickin' undeclared identifier, right? And so that is something that I would like to make more robust and simpler. Let me get a drink, and then there's one more question on here, and then we'll go to Twitch chat. All right, we got snacks. Recently, I've written a lot of code that interacts with a C library that heavily makes use of callbacks. This means that I have to make a bunch of C call procedures that have to then push context to be able to call back. Yeah. What is the reason that led to passing the context being part of the calling convention instead of having it be something like a thread local? Thread local storage. The answer to that is multiple things. There's basically a lot of uncertainty around thread local storage. Like, is it even supported on given operating systems, like, you know, a certain embedded system or whatever? And then do we have to have multiple ways of implementing it depending on the target operating system, which then affects what you can do? Like, I don't want to get into that kind of thing, right? Whereas an implicit parameter always will work. So that's the first thing. Now, maybe it turns out that we're in a modern enough world that everybody supports TLS, but I don't know. So secondly, there is a little bit of a performance penalty to accessing TLS as far as I remember. And there's a question, how bad is that, right? Thirdly, though, the problem is it is invisibly magic across callbacks if you do that, but that might cause problems, right? Like, how do you know when you get to a callback that the context that happens to be there is actually the right one? In some programs, you might be sure about that, right? But in some programs, it might be a very easy way to be error prone and do the wrong thing and have crashes that people aren't even going to understand and they're going to be confused by, right? So this way, when you get a hard error like that, like, oh, there's no context, you know what you have to do. And honestly, since you may be doing it a little bit the hard way because of the old syntax of push context, but what's the thing called? Remap context. So if you look here, we have this example of push context defer pop, right? So you could put this in a macro, and then you just put the macro at the start of your callback, and you have something that makes the right context, and you can just do this. And then it's just one line at the top is the point. You don't have to put braces and then put your code in the braces. And that just reduces the friction enough that it's probably fine. But so that's the reasoning behind that choice, you know. Also, here's the thing. Whenever you're designing language features, there's multiple competing design goals, right? Do you want to minimize friction for interop with other languages, which this is a case of? Or do you want the cleanest, most like error detecting language semantic for expansion into the future? And my observation is often systems, you know, like handicap themselves too much because of backward compatibility with things that then after a couple years become irrelevant, but then the penalty in the design is carried forward forever, right? So Vulkan, for example, has some horrible, stupid crap in terms of like textures. I forget exactly what, but like it was for one or two mobile parts that like aren't even relevant now. And like Vulkan is a much bigger headache than it should be in terms of texture handling simply because of that, right? And now everybody suffers from it. And so I'm always weighing these things, right? Now, when it comes to something like C interop, on the one hand, yeah, we want to help people with C interop. And this is an example of helping, of making it less frictiony to do what you want. But we have to be careful with that, because if we overcompensate and make other things in the language worse in order to enable C interop, it's like maybe that's something that matters less as you scale into the future, because, I mean, take JavaScript, for example. There's a whole so-called ecosystem of code where nobody ever calls into C. I mean, except calling into the browser, right? So obviously it's possible to have a very rich ecosystem that everybody, you know, uses that doesn't do that at all. And so it's like, should I design for that, or should I design for people actually using this language? And I lean in the latter direction, but it doesn't mean that we don't do things that can help when it doesn't have a penalty. The WebAssembly support through the Metaprogram plugin is getting polished, and the only nasty thing left is truncating the 64-bit pointer index to 32 for WASM32. Is there any change in the future that the compiler would have some options to only generate 32-bit pointer indexes? I don't know what you mean by pointer index. If you mean pointer, like, it is a pretty big simplification that we're 64-bit only. Honestly, I don't think 32-bit systems are very long for this world, because a lot of files are more than 2 gigs. And 2 gigs is not very much memory, or 4 gigs, right? Whichever, whether it's signed or unsigned. If you can't like load a file as a string and use it, I don't think that system is very long for this world. And so, like, do you really need to support WASM32? Like, I don't care about browsers at all, right? So I'm not keeping up on that. I mean, okay, I care about them from the position of somebody making a language where people would like to target browsers. Then yes, I need to care about them. But personally, I hate web browsers, right? And so so I don't have a clear picture of the terrain. Like where we should just have a discussion on the Discord for everybody's education, in addition to mine, about like why is there WASM32 still? And is that a backward thing, or is that expected to be a forward thing into the future and all that? Because it's literally a place where I have zero experience, so I have no good answer to that about what is the right thing to do. Because I seriously don't know. Is there anything obvious in the modules folder that can be combined? By the way, even though we announced this at the last minute, it's certainly going with a lot of questions. So that's great. Is there anything obvious in the modules folder that can be combined to make it smaller? Have you found any weird constraints limiting you in making some of the modules? Weird constraints? No. I mean, again, sometimes it's a good test. So like the way the module parameters work was all an answer to the question, how do we do stuff like simp and getrect, where you can import them without thinking about it and you get a default backend, but you don't actually take those dependencies. Like if you don't want a GL dependency in your program, how do you not take the GL dependency and instead use a different backend or whatever? And that I think works very well, although we would like to test that on different backends. So I'm pretty happy with the structure for the most part. Once in a while things come up that it's clear that we should tweak to make better. In terms of the total amount of code that's in there, there probably is a little more than I would like. I would like to remove some things, but it's like not that much. Like go take a look at how much code ships with C++, right? It's way, way, way more than this. And a lot of these are things that people just want. So then you have a question. Well, in some cases, we provide a module like basic that has a bunch of stuff. Like the goal of basic is to just make it easy to write a program where you're not too worried about code size, and it just imports a bunch of things that most people are going to want, right? But like, then do you want to do a lot of things that way? I kind of don't think so, because I think there's one step of conglomeration, which is like basic, like, okay, give me all this stuff. And maybe we put the string module in here. This has like a simple string because I was trying to keep it small, but maybe it's worth putting string in here, really. Because now that we have dead code elimination, which we didn't have when some of these decisions were made, it makes more sense to enable more code to be compiled. I don't know. Okay. At the same time, do you want to pack a bunch of modules into super modules like this? Not really, because I think once you go one step above this, you're more like buying into a framework or an engine. And so somebody could ship a framework or an engine that you like. I like the a la carte way that a lot of these things are. I think that's pretty good. And as I'm glancing through this right now, I don't see a lot of things that I think are horrible. Maybe some stuff like macOS bundler. Is that required to make an executable? If, like, I don't know that much about macOS. If it is, maybe that and Windows resources should be combined into a thing that's like, do whatever you want to do on this operating system for your executable, right? Maybe, you know, so there's a few cases like that. You know, I think it's mostly okay. D3D12 Agility SDK, that's this terrible Microsoft stuff. I think, you know, that we probably should put in D3D12 and make activating that be a module parameter. But like, I look at this, I don't see 2x as much stuff as I think should be there, for example. It's not like that. There's another question about controlling namespacing for globals, like I talked about in the original talk. I'm not really thinking about doing things that way anymore because the language has sort of evolved to do things a different way. Like, one of the reasons I wanted to do that was for helping with thread safety analysis. But you can already sort of do thread safety analysis by just looking at who loads what global, and by making rules that maybe functions in a certain file are not allowed to read certain things, etc. And so I don't know that it's necessary to do things that way. But who knows? Like that's also still a thing that's kind of early. Like we don't have a lot of tools for making sure your program is thread safe, right? And so as we build those out, maybe we can do better. Question regarding the context was not necessarily about the friction of having to push context, but rather more about the cost of repeatedly duplicating the context. Okay. Is there a way to ensure this doesn't become a problem? Well, I mean, if you store it in a global variable, like your prototypical context, then it's just a mem copy, which is not that bad. If you still think that's too much, one thing we could do. So here's the thing. The context as represented by the compiler is just a pointer, right? But push context wants a context by value because it was just like the clean and secure thing to do. But we could have a version where push context lets you give it a pointer. And then you could give it a pointer to a global if you want, or whatever. It would be up to you to make sure, or it could be a pointer to thread local storage, right? Although we don't give you a way to really do thread local storage in that way right now. That's another compiler feature we could add. But then it's up to you to make sure that you're not doing bad thread stuff with that global, right? But yeah, that would be a relatively low effort thing for us to do. Like it's not that hard. Is remap context also usable for things like changing where an array one gets from a function is stored? For instance, I had the issue that I wanted to keep the array view from the lines method in the string value, but that array is only in temp storage. I don't know I don't understand the question. It sounds like you're talking about allocators and how things allocate memory. I don't understand the question well enough to answer it. And we're kind of getting toward the end of how long I want to do. So you could ask this one offline in more detail. How would it be possible to compile to extensions architecture ESP32? That sounds 32-bit. Like I said, we don't support 32-bit right now. Again, that's a deliberate trade-off where we are intentionally not targeting some systems in order to maintain simplicity of language semantics. So like, you know, in C, there's a lot of data types where it's like, you don't know how big they are, and we didn't want to do that. Now it is one step more certain to say, well, it's either 32 or 64, depending on which thing. But I just wasn't in the mood to add that complexity, and it would be a hassle. So if we ever do it, it'll be later. I would rather never do it, honestly. And the question is just, are future-oriented people still building 32-bit systems, or are those legacy? And I'm not sure. I don't know. I'm not knowledgeable about the embedded world, so I don't know. So again, that's information that would help us make a good decision there. But in general, if something would make the language worse, but it seems relevant now, but the time frame for that relevancy is like 4 or 5 years, and then it'll be irrelevant, I am loath to permanently compromise the design of the language to accommodate those things. 4 or 5 years ain't that long on the kind of time scales I've been working on, right? Are we considering limiting, weakening any other language semantics for the purpose of simplifying the implementation? For example, polymorphism and overloading seems to be a constant source of minor bugs. That's always a concern, yes. if we can't, for some reason, implement something robustly, then that shouldn't be the language semantic, right? When it comes to polymorphism, yes, it has been a source of bugs. However, often those bugs have led to changes in the implementation that make the implementation more robust. But yeah, there's a question in the end, is it worth it? The problem is I don't want to get rid of polymorphism and I don't want to get rid of overloading. And then those are fundamentally interoperating features. And so, like if I got rid of one of those two things, I would get rid of overloading. Right? But the problem then is, and polymorphism is the complicated part. So we're sort of just signed up to make it work, right? And sometimes things are complicated and you just have to make them work. Really the thing that makes those complicated, it's not exactly polymorphism or overloading. It's those things combined with the nonlinear compilation that's the real bitch, right? Because it's not just, like you can't just do polymorphism. You might have to be able to stop it and pick it up again at any time later. And that's what makes it complicated. And forgetting to do that correctly is a source of bugs and whatever. And so that's just kind of what we signed up for. But again, if in the end we cannot, like literally cannot make it work despite putting more people on it, then I don't know. Then you got to ask some fundamental questions. But I think it'll work. It basically works now. Like usually when we have bugs, it's because they're just stress test cases that we don't do. Like in terms of my day-to-day use of programming the games and stuff, I don't really run into polymorphism bugs, right? It's usually people doing something different that's off the beaten path. And so that's fine. We fix those things when they come up. Yeah. Re-macOS bundler, it is necessary Mac executables work, but they are terminal based. You have standard GUI, double click to open. Yeah, so that is a thing that, so as a basic statement of what we're trying to do, like along the line, so I should be able to make a program. It just uses simp or whatever to draw, and then I want to compile that for Mac, and I want that to work. And I shouldn't have to think about importing a bunch of weird modules just to make my windowed thing work on Mac, right? And so we should structure things so that's not necessary. So whatever that means, you know, like I said, we have this Windows resources module, and what that really is here's the stuff you might want to do if you're compiling on Windows because Microsoft has made it stupidly complicated. Here's just, you know, how you set the icon and how you write the stupid ass XML thing into your executable. Like XML should never be put in an executable, but it was, so it is what it is. You know, so this macOS thing is like similar but different, right? And so what that should really be is refactored into the module that's like the stupid crap that you have to do because operating system people don't take their jobs seriously anymore, basically. All right. Re-WASM 32, WASM 64 would probably be widely supported in the following 2 years, so there's maybe no point in supporting 32 from the compiler perspective. It can provide partial support with an external truncating program. Yeah, that would be my preference. I'm not very 32-bit. Like I said, if you can't even load a 4 gig file, I don't, you know. Like, dude, we're talking about large language modules that are like many terabytes. It's like, how are you going to deal with that in 32-bit, right? It's just, it's gone. I think it's gone. Like, even embedded systems are going to want to run like AI stuff, right? Like if you can't address more than 4 gigs, you just can't do that kind of thing at all. So, yeah. Okay, I'm going to take a little bit of a voice break, but does anyone have amazing... I'm close to wanting to end the stream. It's been 2 hours. Does anyone have amazing questions in Twitch chat? Like the best question. Non-noob questions, because you got to realize I've answered the newbie questions like 700 times. Does unrolling to enable usage of SIMD operations still give enough benefit to be worth it? I mean, it depends. So here's the thing. So compilers will do auto vectorization, they call it, which is when you use the SIMD instructions. And you do often get a measurable speed up from that. You don't get anywhere near the speed up that you get from a competent programmer employing SIMD, right? Like a competent programmer employing SIMD can make things 10 times faster. Auto vectorization makes things 1.1 times faster or whatever, right? It's like not even in the same league. And so there's a question of what should the compiler be doing? Should it be trying to auto vectorize all over the place? I don't know, maybe. Or should it be making it very easy for you to vectorize? Like, again, I don't think so. You know, loop unrolling is not really what you do to make vectorized code fast. I mean, you can. It's one of the things you can do. But like usually it's replacing a loop with a different loop. So for example, in the standard case now of instead of parsing something character by character, we're going to load it into a 16-wide SIMD and use a few instructions to do like a 16-wide search in a couple cycles, right? That's still a loop. It is a loop 16 at a time, but like it's a different thing than unrolling. This is what I was saying before about like the thing thinking it should remap you to the fastest program. Like it's very hard to get to the good loop for that by starting with a character by character comparison and unrolling in a general optimizer, right? Like if you write very specific routines to detect that very specific thing, which might be worth it because this is a pattern now that people understand, then you could maybe have an optimizer that outputs that. But that's not really general loop unrolling either. That's like, okay, I'm going to make this loop do a different thing. But it's like, as a programmer, when you do that, you're writing a different loop. You're not unrolling the loop. You know what I'm saying? It's just a loop that happens to go 16 at a time. Wouldn't have thought vectorization to be that ineffective. I mean, it might be more effective in specific cases, but broadly speaking, even the people whose job it is to like champion loop vectorization or auto vectorization because they work on it, it's like 15%, I believe. Last I checked was like the marketing number for speed up. In a lot of cases, you won't get that, right? But in some cases, you might get more than that because that's just the way code is, right? How can you know if something is a bug without a specification? Well, you go to Klaus Schwab and you say, should I eat this? And if he says yes, it's a bug. Okay, seems like that's all the questions. So thanks everyone. This, for some reason, my voice got more strained in the middle. I'm trying trying to learn how to not strain it so much when talking. Hey, now this is a lot better. Yeah, thanks. We're doing these. If you haven't been to one of these before, we're doing them something like once a month approximately. And we'll do another one once a month approximately. Thanks a lot, everybody. And see you later on. Have a good evening. We'll post this probably on YouTube if you missed a lot of it.